So, welcome to episode number 7 of the Graph Show. Today, we'll be talking about Apache TinkerPop, and with me today is Stephen Mallette, really the driving force behind TinkerPop for quite a few years now. So, Stephen, welcome. I was hoping you could just kind of give us an overview of the current state of TinkerPop, maybe tell us about the recent release, some of the things that have been going on in TinkerPop development and in the TinkerPop community lately. Maybe talk a little bit about the near future of TinkerPop if you're up for it. So
sounds good, and thank you for having me here to talk about TinkerPop for a little while. Regarding recent things and what's happening in the community, we just recently released version 3.5.0 at the I guess around the beginning of May, and that was a pretty major release from recent years. There were a number of important changes in there worth talking about. We did lots of things like upgrade major runtimes and major dependencies and so forth. But there were also some neat features to talk about, like the inclusion of Gremlin. Some folks may have used Gremlin in their day-to-day. It was a project that was developed outside of the kind of official TinkerPop community. It was a third-party project, and it's basically a linter and syntax formatter for Gremlin, which helps tame. I used it all the time to help tame really complex single lines of Gremlin that you get from users and folks, and formats it to sort of a canonical form that's much more readable. And so, using it as much as I did, I kind of thought, that's something that a tool that would be helpful both, from a perspective of tool builders who are building. There's a number of different like IDE type tools out there that folks use, and it'd be helpful to have that established in TinkerPop as something official that produces kind of an official way to format Gremlin. And so we brought that in as part of 3.5.0, and we'll be making like the first official real release of it as a library in 3.5.1. But the code is actually in 3.5.0 at this point. We also did some things with another area where folks kind of we got kind of a quiet feature of Gremlin translators that convert Gremlin between different language variants. So, you might write some Gremlin in Java, but want it in Python, for example. And that feature was kind of always there in TinkerPop. We used it mostly internally for testing, but it kind of got out into the wild and people started using it and really having a need for it. Folks use it a lot for logging with Gremlin, for example, where you might need to get a Gremlin traversal and convert it to a string form so that you can properly write it into a log. So we basically expanded that functionality pretty greatly, covering, I think, all of the language variants, going from Java to all of the ones that we officially support, which is right now Python, JavaScript, and .NET, as well as Groovy. And so we have all those, and then from each of those variants, we have ways to get back to Groovy at this point. So Groovy in Java. So that was like kind of a neat thing people were asking for. That's it's just kind of a subtle, small thing, but again, like a feature that I think a lot of folks were looking for over the years. And I think
let me interrupt for just a moment. So how does that relate to? I know you're probably going to talk about Gremlin language, which you added, which has an ANTLR grammar for Gremlin,
yes,
and so on. So how does that relate to the translators?
Well, I guess that's a good question. I think at this point there isn't a ton of connection there, except that you are able to generate parsable, I guess, AST parsable Gremlin with Gremlin language from any of those other languages, right? So that's about, I think that's about the extent of the connection at this point. And I guess as we spend more time expanding where Gremlin language is going, we'll see how we'll see what else that might mean going forward. I don't know if there's like, maybe it might present other ways. I don't know if we'll be able to leverage Gremlin language in some way to better do these kinds of translations. Right now they're fairly, some of them are really, they're really relatively simple bits of code, but I don't know if there's something more we might be able to do with Gremlin language in the future to help make that easier or do more testing or something along those lines. I think another feature with those translators is that a lot of examples in Gremlin tend to be written in just the Gremlin console, right? People ask a question, and the natural thing to do is go to Gremlin console and develop the answer. And that's going to be in a groovy Java sort of form. And typically the person asking the question potentially is going to be using Python or some other language, and having a way to easily convert that big blob of Gremlin over to something that they're familiar with ends up being a lot easier. Yeah, no, I don't think there's any other real connection with it just yet with Gremlin language.
Sure. Well, I mean, similar question with Gremlin. So, all three of those new features essentially have something to do with reading Gremlin traversal expressions in and writing traversal expressions back out. So do you see any connection between, say, Gremlin and the translators?
Yeah, I wonder. I mean, right now, I'm not completely familiar with all of the intricacies of the Gremlin code base, which is written in JavaScript right now. But I wonder if there's a way to better leverage Gremlin to make some of that parsing easier to do, right? And formatting and so forth. I think that probably might make some sense as we continue to look where Gremlin language is going to help fit in. We do have, obviously there's that gap between something written in, I guess JavaScript. I guess we could use there must be some form of ANTLR processing in JavaScript that we could leverage to read that AST, read the ASTs and do stuff that way. So we'd have to look to, I guess we'll look towards the the person who's the kind of the mind behind Gremlin. I don't know how to say his whole name actually.
I'm guessing Oyvind.
Yeah. Okay. You're better than me. But yeah, that sounds about right. So we'll, I've never actually spoken to him in person, so I don't know. It's kind of one of the interesting things about doing open source development is you meet all kinds of people, but you really don't get a chance to meet anybody at all. So, but yeah, well, I think that could be a direction that might make some of that code a little bit easier to manage and deal with. And keep up to date, really, because I mean, if we're driving the Gremlin language by way of that module, by way of the Gremlin AST, then that's going to become like kind of the focal point for Gremlin syntax going forward.
Sure, and kind of along the same lines of tying it all together in terms of being able to translate between variants. What are your thoughts these days on a formal semantics for Gremlin? And again, how does that maybe relate to Gremlin language and the other features?
Yeah, I think we're kind of reaching that point with Gremlin where we've driven it so long by way of Java, and that I think it's kind of we see where that kind of has its limitations. Or creates problems for Gremlin and other languages. Up until this point, Gremlin has largely lived on the JVM, and it's only in, say, the last several years that it's extended off of there, and having found its way to Python and .NET and so many other different programming languages at this point. There's definitely some issues with driving the language by way of just adding a new step in Java and not thinking about it more in terms of what is this doing to Gremlin, the language itself. So I think what we'll be seeing more of, as now that we have this in place, is that we'll be driving Gremlin language development kind of independently of the languages that are out there, and then we'll adapt each language to the functionality that we kind of come up with by way of the, as you put it, the formal semantics of the language itself. And hopefully that'll bring a lot more consistency to Gremlin. There's like just so many little corner cases about that I've run into. Some folks I work with, inside of Neptune. They're looking at things like equality of certain data types and things in Gremlin, and there's always these little odds and ends that kind of stick out that we didn't really either quite think of or might not align exactly right between Java and say Python or JavaScript. And so I think if we're driving this more by the Gremlin language model, maybe we'll come out a little bit better than we have in previous years.
Sure. Any thoughts on denotational versus operational semantics for Gremlin? Because it's kind of an interesting beast where you can look at parts of it as a declarative traversal language that with no side effects, and then of course there are operations in Gremlin, steps in Gremlin that modify the graph. So any thoughts there about what is the right way to specify the Gremlin language, and what is the right way to think about the semantics of Gremlin traversals?
Yeah, I mean, I'm not sure I've gone too far down that direction just yet. I mean, I think as we've gotten we've just gotten Gremlin language module in there, and I think these are the types of discussions we'll end up sort of having more of. In understanding more about the those sorts of aspects of it. I think Gremlin's nice in the sense that it has that kind of flexibility where you do have that side effect free aspect to it, but then there are those other parts that so I'd hate to lose some of those perks of Gremlin in the process of trying to formalize it more, in terms of even like data types and things. I'm sure we'll maybe touch on that part of that discussion somewhere along the line here, but I hate to lose some of the flexibility that Gremlin has, especially with a graph like TinkerGraph that's purely JVM based, can hold any object, any JVM object you like as a property value. You hate to lose some of that in favor of kind of a greater formalism, so to speak, and greater restrictions. So I think we have some discussion there. I'm not sure how far down the line we need to go before we get to that kind of discussion, but I think there's definitely some like maybe lower hanging fruit to start looking at as we go into 3.6 and 3.7 and 3.8 and so on.
Yeah, I think there's always a little bit of a dynamic, a little bit of a tension in property graphs between what is most immediately useful and relevant to developers creating applications, and more formal aspects of graphs and query languages that are useful for optimizations. So
I think I think we definitely want to think about what's been kind of hurting our users the most, and those things aren't necessarily these little inconsistencies and and formalisms and missing formalisms and so forth. They're really simple things that don't get a lot of shine, and so but they're the things that are also, I think, holding folks back perhaps the most. So yeah, I as much as I want to like tackle some of those bigger issues, at the same time, I think a lot of the recent years and 3.5.0 they've been mostly about like trying to deal with those sorts of issues that users have been having.
Can you give some examples, like what's holding developers back?
Yeah. So I know that like in 3.5.0, for example, I think I was going to mention that's where we started with some of the things that were kind of current. One of those items was a fairly late addition to 3.5, but was something that just kept coming up, again and again. So to start with, in Gremlin server, we made a pretty major change by adding something called the unified channelizer. And what that effectively did was it combined all of the different ways that you kind of communicate with Gremlin server into one single pipeline. So you're able to do HTTP, you're able to do your WebSocket communication sessionless, you're able to do your WebSocket communication inside of a session, all through one singular pipeline. And what that further did was it also unified the thread pool that was processing that, all of that incoming traffic. So prior to this, if you had a session, that meant you started up your a special thread pool, a single executor thread pool just for that particular session. Okay. And that was not a big deal if your session was meant to be some long-lived operation, right? You could bury the cost of starting and stopping that thread pool and destroying it inside of, a 10-minute or longer session, and no one would know the difference. The difference ended up being between making the choice with that and the fact that, if you had a short-lived session or a medium-length session where you only had, a few mutations that you needed to make, maybe you need to check for existence of some things, that session ultimately started costing you things. And obviously, if you open too many sessions at once and each one is getting their own thread pool, that ended up being a fairly expensive thing for Gremlin server, which is why we didn't really want to encourage a lot of use cases around using that, and encourage more about like long-lived sorts of use cases. And so with the unified channelizer, we unify those thread pools so that it's one thread pool for all of those things. When you open a session, it uses that thread pool. And so for those sorts of workloads, those medium to long or medium to short sorts of operations with Gremlin, you get really good performance compared to where you were before. And that led to a second idea, which is really the problem that a lot of folks had, was that ultimately folks needed to do remote transactions, and that's something that's been missing from TinkerPop for a while. We've had to encourage folks to do transactions by way of a single request. So you had to figure out how to write your Gremlin in such a way that you could get it to do everything you need to do inside of one Gremlin query, which could lead to some extraordinary Gremlin queries and extraordinary Gremlin query writing, which were complex to manage and maintain. So now we have this notion of remote transactions, and you can do them, and that brings together both sort of the embedded API for doing transactions that everyone knew about, the g.tx sorts of transactions where you could roll back and commit. And now you have that same functionality for remote cases, and that also now would extend to language variants. Okay, and that's where a lot of folks had a lot of trouble, is because you'd be using Python, and you had no options for doing any sort of transactions beyond, again, like the single request equals one transaction sort of thing. And so I think this is going to change. Right now we'll have support for g.tx in 3.5.1, which is under review right now for release. And then hopefully by 3.5.2, we'll have it in the other language variants. So you can do it in Java, and you'll have it in JavaScript almost immediately, and then we'll have it in the rest soon enough. But I think this is going to drastically change the way that people write applications for Gremlin, because so many are remote use cases now, because so many people are off of the JVM. And so instead of these big queries, or people still submitting scripts for sessions, with the increase in performance that you're going to see with the unified channelizer, I think folks are going to really change the way they're building their applications. Maybe go back and change a lot of existing code to simplify it, make it easier to maintain, and break up some of those big blobs of Gremlin into stuff that's much more manageable.
Awesome. And maybe could you just briefly sort of say what was difficult about making remote transactions happen? So I can comment on like the early days of TinkerPop 3, when it was sort of recognized that different systems basically had different notions of transactions, and it was hard to unify them. So what was sort of the key idea that allowed that now allows remote transactions in TinkerPop?
Well, as it turned out, building the remote transaction component wasn't extraordinarily difficult. And it's one of those things where you think something is going to be kind of hard, and it ends up being easy. And then like other times you do something that you think is going to be easy, and it's like almost impossible. So the actual implementation wasn't so hard. I think that some of the issue had to do with taking the risk to go build the unified channelizer in the first place to get the thread pool right, because it would have been almost senseless, I think, to try to continue with to extend Gremlin server to be used in such a way that you had all these short-lived transactions or medium-length transactions being executed against single-threaded thread pools all over Gremlin server. Like it's too hard to predict how you would size something like that. And so we needed something more stable on the server side. And I was never sure how complicated or how hard that was going to be to do that. And it ended up being not the worst thing to develop. I also think at the time there was definitely a push to, I think we were thinking there was going to be another way. I think I was waiting for another way for remote transactions to materialize, and it wouldn't be by way of Gremlin server sessions. And that approach, whatever I thought it might be, never exactly materialized. Like remote transactions, like no other way came up as a way. And so we already had this thing that existed for years, pretty much since Gremlin server was created, even going back to Rexter, it existed, this notion of a session that you could send scripts to, and it was bound to a single thread pool, and that was it. And so, I think I was waiting for some brilliant stroke of genius to come along that never exactly materialized. And I also think there was also a push for a while from, to maintain the notion of Gremlin was always going to be a sessionless thing. There was also another argument where you'd say Gremlin would always be kind of a sessionless thing, and we'd build transactions into the language itself somehow, and that didn't quite materialize. So as a result, I think it came a little late, and it came probably as expected it would, but we have something now, and I think it's going to really change the way people do things going forward.
Thanks. And we will get back to 3.5.0. I promise that. I want to ask about lambdas. What do you think is going to happen to lambdas moving forward?
Well, I think one of the things we always looked at when we were thinking about TinkerPop 3 was we were always thinking about how to make it so that users, the Gremlin didn't need lambda expressions. How can Gremlin be designed, and Marco Rodriguez and Daniel Kuppitz did a lot of thinking in this area to ensure that we had, I think the number we used at the time is, how can 95% of Gremlin be lambda-less? How can it be how can the language be structured so that we don't have to have it? Because if you remember, if you were been around TinkerPop for a really long time, and going back to TinkerPop 2, Gremlin was definitely kind of a lambda heavy language. It was built out of Groovy, and everything was Groovy oriented, right? So you basically passed a Groovy closure as an argument to a ton of the various various steps that Gremlin had. And so a lot of work was done by both of them to come up with a way to ensure that we didn't have that. So that 95% was the number we were looking for. As it turns out, I think the 5% that's sort of remaining, and maybe it's even less than that now, end up being wrapped around basically primitive operations. And this is the main gap, I would say, that Gremlin has to, say, Cypher and GQL, is just the ability to easily concatenate strings, slice up strings, do basic date operations. Those are all things that we typically have to relegate back to the client side. You get your results back and you have to do it there. So I think for lambdas, we want to continue to further reduce sort of the need for them. And that would adding the primitive operations, primitive functions would go a long way to doing that. And then I guess we'd look at it again and say, well, what else is there? What else would be next? But I think we'd be looking to try to continue to limit them, because extending, I don't think we want to have, a Groovy like language embedded in our language anymore. And that's the way you do things now. If you're in Python, if you're in C#, you basically have to learn how to write Groovy lambdas essentially to pass those sorts of operations on. And not every graph even supports them. So you might be out of luck if you're not using, say, just raw Gremlin server, and there's a number of issues with dealing with that, with security and all kinds of things. So I think that's kind of the direction, at least immediately, is to think about, how do we get the next 5% or 4.9% of cases out of the way, so that we're closer to not having to have lambdas at all.
Sure. Do you think we have a pretty good handle on the scope of that library of primitive functions that is needed? Like string functions, there's arithmetic functions, there's
I know there's folks thinking about it, but nothing has been brought forward as of yet into the community. I think we'll see that kind of coming for further discussion, and try to come up with what it is that we need to have to satisfy all of those things. It could be a fairly lengthy list. I mean, if you just look at other languages, if you look at GQL, if you look at SQL, there's a good number of things that you'd need and want to have in order to satisfy and be on the level of those other languages that are out there. So it could be a fair bit. I think some of that bases in something that you're kind of really interested in, which is the data types, having some kind of specified type system in Gremlin. Often when I'm thinking about like how to add dates, for example, it's like I'm never quite sure how we want to do that, because we don't have like an actual date type really defined in Gremlin. I got a date time, I got time zones, but that's all like Java oriented stuff. How do we get that to be more language level sort of thing?
Yeah. So yeah, kind of fleshing out that library is going to be interesting. But yeah, I totally agree that that's something that can help avoid some of the need for lambdas. So that was a long digression on kind of things Josh is interested in. Any other features of 3.5.0 that you want to talk about?
No, I mean, I think those were some of the top things. I mean, we did do some other things like that tried to bring Gremlin a little bit more in line with some of the semantics of Cypher. In one case, like we added, made it so that there could be null traversers inside of Gremlin. So before this, if you generated a null inside of Gremlin, it basically meant you were just that was the end of the filter. You were killing the stream effectively, and now null can actually flow through the traversal stream, and that again, that brings us a little closer to how Cypher does things, which I think was probably a good move. And I think it's also closer to how, folks coming from like SQL backgrounds, they're used to dealing with nulls from relational databases, so that was probably a good thing to add. But there's a pretty long list of items in our upgrade documentation, but I think I hit on the top ones I'd want to talk about today.
Did you want to talk about security at all?
True. I guess we could. Yeah, that's a little something that's maybe we have the foundation for in 3.5. So with the addition of Gremlin language, that is going to set up a situation where we can reduce our reliance upon Groovy, right? So to this point, we all the scripts, string-based Gremlin that come through to Gremlin server are all processed by way of the Groovy script engine. And then your miles may vary, right? Because depending on the graph provider you're using, this may or may not completely be true. But if you're a Janus Graph user, if you're using Gremlin server, just open source Gremlin server, Gremlin Groovy script engine is what is processing your Gremlin. And given that it is a script engine, pretty much anything you send to it will execute on the JVM. So you have access to largely the entire JVM when you do this. There are some ways to try to limit that. We have some examples. They're not really production sort of level things. That are meant mostly to inspire folks how to build something, and some providers have done that. But with the addition of Gremlin language, we'll be looking to write some kind of script engine implementation that will parse Gremlin to the AST form and execute it that way. And we'll produce traversals essentially from the AST. And in that way, we'll have a much more secure approach to dealing with Gremlin scripts. So we'll have basically the bytecode form, which has traditionally been secure, and then we'll have we'll have the script approach, the string script approach that everyone else that we've had for a long time, and both will work well. And we'll have it. I guess we're going to introduce it basically as an option for folks to choose if they want to use the AST form. I suppose the effect for a lot of folks will be, if you were using Gremlin server to accept scripts that would potentially interact with a schema, for example. Like if you were using Gremlin server to change and modify schema of your Janus Graph instance, obviously you need the Gremlin Groovy script engine to do that. Our AST isn't going to process that. I do think we might need to consider, I don't know if, well, maybe we do or don't. I don't know. This is up for discussion. How does a graph provider extend upon the schema? Extend upon the AST, right? Yeah. Like how would you add your own custom functions if you had any, or custom steps? How would you add a schema language and make that plug directly into Gremlin server? I think all those things are kind of up for discussion at this point. So I think there's going to be a lot of discussion. I mean, you've kind of like got the conversation that we've had so far. Like we keep coming back to what Gremlin language might do. I think it's going to do a lot based on what we're talking about here.
Yeah. I've thoughts on that last on the domain specific extensions. Watch for a video from me. So another thing we chatted about recently was version compatibility. Do you want to say anything about kind of? Yeah, absolutely. I think, and that probably starts with 3.5, so I could probably include it as part of that category of things to talk about. One of the issues that I think, again, you asked about what kinds of problems are like, bugging users, and I think this is another one. It's just something as simple as, what version do I use of TinkerPop to be compatible with another? Right now, there's a fairly complex compatibility matrix
of, what works with what. And it's not even really easy to document, because it might be that 348 client works perfectly well with a 346 server if you don't use feature X, right? Or if you don't rely on behavior Y. And that's really hard to reason about. So what I think is going to make a lot of sense for us going forward is to try to make it so that this becomes a whole lot easier. Going forward, I'd like to be able to say, if you have a 3.5 anything client, you can talk to any 3.5 compliant server, and that'll do a couple things. I think one thing it'll do is it'll allow us to kind of focus on more feature-oriented functionality going forward. We won't have like these deep patch releases like we've had since 3.2, 3.3, and 3.4. I mean, 3.2 went to 3.2.11, 3.3 went to 3.3.11, 3.4 is on its way to 3.4.12. We're really going to focus more on moving forward on the minor points in a version. So we'll see 3.6, 3.7, and so on. And that should make it really easy for folks to reason about, what works well with what. I think it might put a little bit more pressure on providers to move a little more quickly to adopt new feature versions, but we have control there in TinkerPop. We can control what what breaking. Maybe we can even release non-breaking minors. That might be an option if we want to increment along that kind of line. So hopefully I think we'll try and cut down on the long range things. And try to focus on just on the minor releases and getting patches to fill in functionality where we don't have it. And by that I mean, like for instance in 3.5.0, g.tx released for remote transactions, but it only supported Java at 3.5.0. So the language variants, Python.NET and C and JavaScript sort of lagged behind that a little bit. And what we'll use the patch releases to catch all those up. I think the idea would be to try and get a feature out in Java for folks to consume. Maybe we get some feedback on them, and then fill in the functionality on patch releases and get those in as early as possible. And don't give up on a patch release or don't give up on a minor line until we've brought all that functionality up to the same level as Java. And I think that's maybe another topic too that requires some discussion is, how do we keep feature parity in all of these different language variants, right? We're maintaining, 4 or 5 different language variants. I think there's potential for even a 6th. I guess I can say that now. So I think I haven't proposed this just yet, but I think if we were looking at another official programming language to support, it would probably be Go. I get more questions about Go than anything else. If you look out in the community right now, there's like 5 different Go drivers by third parties. And that typically tells us, in the past, that's told us that people are interested in that. They're not finding the features that they want in those existing things. And, there's disparity. And when we have 5 different, 5 different versions of a particular language variant, people don't know what to choose, right? Like, which of the 5 is the right one for me? And so, is it going to have all the features? Is it going to be on the same level as, the Python, the JavaScript, and so on that's officially supported by TinkerPop? So it may be that Go would be sort of the next thing to start looking at. So, but then again, you add Go, and it's like, all right, now we're at 6 languages. How do we maintain all this? How do we make sure that the features stay up to date? Can we do anything to reduce the burden of managing all these things? So I think all that's kind of up for discussion as well.
Sure, and it's sort of having ways of just keeping the APIs consistent across language variants, I think, goes a long way. What are the other aspects of parity that come?
Yeah, definitely that part. I think Gremlin language should help with that.
Yeah, I think so too.
I think you've demonstrated that essentially. So I think that's going to help. We have experimented with basically language generation. That's basically how these language variants started. Python was generated. That's how Marco built the first one, but we basically used reflection over Java. So again, Java driven, and Groovy scripts and Groovy templating, which ended up not being terribly maintainable over time. And the worst part of that was that I think it discouraged new contributions from people, because if you're a Python developer, you don't want to have to know about Maven to do your contribution, right? And that was how the templates did their generation. You did Maven clean install, and then it did the code generation for you. And if you didn't know about that, you would change the generated code and not touch the templates and so on. So we need to make sure that whatever we learn from our mistakes there, and if we were going to do some more kind of code generation in that area with Gremlin language, we should try and do that a little bit better. Maybe it's done natively by way of each language. Like do the code generation out of Python. If you're in Python, do the code. I don't know, something like that. That way, so a Python developer could actually contribute to it. But as far as other things that would be problems, I think we'd want to look at kind of the network and serialization, network protocol and serialization layer for these things. We spend an inordinate amount of time managing the WebSocket and serialization functionality. I mean, we're three serialization formats in at this point, with a few versions in between. I mean, there's GraphSon, Gryo, Graph Binary is the newest one and the best one at this point. But maintaining and managing those is an expensive part. Yeah, and GraphML. That's an expensive part of this. If we tried to write Go tomorrow, I'm almost certain you'd spend most of your life writing serialization code. I bet the Go driver could be written in very little effort, but for supporting the WebSocket protocol. But the serialization is just brutal. There's too many types, and again, they're too bound to Java, and it's a little bit more than we need to have. So if we could come up with some way to leverage something that handled that. You've done some neat things and shown off some neat things with Thrift recently, whether it's protocol buffers or whatever it might be. Those things didn't quite satisfy us. I mean, people might ask well, why didn't you do this from the beginning? At the time when we first started TinkerPop 3 and Gremlin Server, we looked at those things and they didn't quite fit the model for what we expected TinkerPop 3 to be. But now that we see what it is, and now we see people are using it, I think, and of course, protocol buffers has changed considerably since I last looked at it. I think there's a good chance we might be able to use that to potentially be a way to better maintain these new language variants, and bring more of them potentially in house. I mean, I think when they're official, and that's not to take anything away from the third party libraries out there. I mean, I love when I come across a new one. It's great to see, when you see a new language, there's a Gremlin in Elixir. I mean, there's a Gremlin in Rust. I did a whole talk about all the different, I must have compared 17 different versions of Gremlin. I probably bored a few people to death doing it.
We'll put a link.
Yeah. Yeah, I don't know. If you didn't like Gremlin and you didn't like programming languages, you probably had a long hour listening to me. But I thought it was fun to look at that stuff because I like Gremlin and I like programming languages, and seeing how the different idioms that are presented to do Gremlin, and you can kind of see what's the same and what's sort of different. So in any case, like I said, I think we can figure something out there. But there's definitely a lot of discussion in that area to still be had.
Well, while we're on the topic of open problems, anything else you'd like to mention as sort of developer pain points, or looking ahead towards TinkerPop 4 that you think we need to do?
Let me see. I think there's still, if we were talking about some other areas that we might look forward to in the future. Another area that's kind of solidified now is geo predicates, and geo objects like points and shape. There's enough graphs supporting that now that TinkerPop can probably jump into that area and try to unify around that. So I think we can expect to see some more stuff there. I think we're still missing probably a few text predicates. People always ask, like, number one, people always ask for like regex, and we've not supported it for a number of reasons. And I don't know, there's still some questions about exactly how we do that. I guess we just have to pick a version of regex that we're going to support, and go with that. But that's usually the blocker with that one. Yeah, I think those are the major things to start to kind of be looking at for in changes to the language itself, is like the primitives, additional predicates, and that'll, we'll see what comes kind of after that. But I know those are the ones that are kind of hurting people right now when they're writing stuff. And I guess to some extent, consistency in the language, which again will go back to formalism, and trying to formalize Gremlin a little bit more, and making sure that we cover a lot of the edge cases, because nobody wants to be surprised when they go run their query and it works one way on one graph, and then you run it somewhere else. I mean, that's the whole point of TinkerPop, right? You're supposed to have this language agnostic way for dealing with your graph. And if there's a particular strategy or a particular formula of steps that doesn't behave the same way every time, it's painful.
Yeah, so I agree that kind of a little bit of a focus on interoperability is going to go a long way. But so I think we could continue talking about some of these things for another hour. But I thought I would maybe close out by just taking a look at the developer community, the vendor community, like who's doing well at keeping up with the releases, who's doing good work in TinkerPop these days.
Yeah. So immediately, Janus Graph is pretty close to having 3.5.0 support. As it stands, I think they might be the first ones to get like to get that release. I don't know all, like, what every graph is doing, but they've been instrumental in moving forward the 3.5.1 release, which they want to have in order to do their official 3.5.0 or 3.5 line release. So Florian Hochman is a PMC member, is handling that now. And so that'll be interesting to see. I think that'll be like the first, maybe the first real, I guess the first real sort of look at how 3.5 does in the wild. I'm sure people are using it with TinkerGraph and maybe Neo4j, but I think Janus Graph will be like kind of a real initial test of what's happening with 3.5.0. I know we're working on 3.5.0 support inside of Neptune, and because I'm doing it, so we'll see how that kind of comes along. And I know I actually just saw some interest in having in the Bitsy graph database having 350 support. I think folks kind of want to see it in different graphs. So if graph providers are listening, I think folks would like to see the upgrade to 350. I know there's a number of interesting number of interesting graphs coming from like Alibaba and Huawei. I don't know. I'm thinking that they're keeping up as well, because I have seen some communication, that seemed to indicate that there was some activity there. So I don't know. We'll see. We'll see who's see who kind of gets 350 instances out quickly, and see what kind of reaction we get from the community when there's a lot more real usage.
Sure. What about developers? Like, how can developers who haven't used TinkerPop best get up to speed on TinkerPop and Gremlin, get involved? Are there opportunities for contributing?
Oh, when I started with TinkerPop like a decade ago, it was really easy to just jump into the code base. I think you guys had maybe 9 months worth of code in those repos when I got started, and it was easy to kind of get in there and figure out what could be added and what could be done. And TinkerPop was just kind of a possibility to certainly a JavaScript or you were a developer, there's opportunity to help on those things and making them more likable and more idiomatic for developers of your favorite language, right? I think we try to look for ways to make Gremlin feel like it should in a particular language. If you're in Clojure, you want your Gremlin to feel like you're doing Clojure, not like you're writing Java inside of Clojure. So those kinds of wrappers, any experience that would help make that better should be easy. And getting into the language variants are actually, that's a pretty easy area of code to kind of jump into like just right away, because it's relatively lightweight. There isn't a ton of code there. And certainly if you have expertise in those areas, where for the most part, most committers, like core committers in TinkerPop, are like mostly Java oriented folks. So that kind of leaks sometimes over into other languages. So it's helpful to get some perspective from developers in other programming languages. So check out the website, TinkerPop website, the homepage. It has links to where to go, right, and how to contribute, and how to build, download the code and start building it, and that's pretty much it.
All right, Stephen. Well, it's always interesting to talk to you. Thanks for being on the Graph Show.
Yeah.
For everyone else,
thank you for having me.
Yeah, check out datageeks.tv for past episodes. This has been Josh Shinavier and Stephen Mallette. Thanks again.